If you answer Web API security like this in 2026, you fail the interview immediately. Senior interviewers are tired of hearing 2018 textbook answers. They ask, how do you secure an API endpoint? And you say, I add and store the JWT in localhost. Boom, rejected. Because modern .NET engineering has changed. Today, I'm breaking down 5 advanced .NET Web API interview scenarios that senior candidates are getting grilled on. Master these 5, and you won't just sound like a developer. You'll sound like an architect. And I've compiled the code templates and architecture diagrams into a free PDF cheat sheet. The link is in the pinned comment. Scenario number 1. Web API, Security and Identity. The interviewer asks, how would you secure a SPA or mobile client communicating with your ASP.NET Core Web API? The trapped answer? I issue a JWT, send it to the front end, and save it in local storage. That sounds reasonable, but in 2026, it's a red flag for browser-based applications. Why? Because storing raw access tokens in lodged local host increases your exposure to XSS attacks. A senior-level answer should introduce the BFF pattern, or Secure HttpOnly Cookie Delegation for browser clients. The important principle is simple. The raw access token should never unnecessarily live in browser storage. But don't stop there. A senior interviewer may ask, how do you handle authorization? Instead of creating dozens of static roles, talk about policy-based and requirement-based authorization using IAuthorizationHandler. Then, bring up something many candidates forget: token revocation. Local JWT signature validation alone doesn't solve every security problem. You can validate the token signature locally using public keys, while maintaining revoked JTI information in something like iDistributed or Redis. That gives you a hybrid approach: fast local validation plus centralized revocation checks. That's the kind of answer that moves you from simply knowing ASP.NET Core to thinking like an architect. Scenario number 2. Global exception handling and API resiliency. The interviewer asks, how do you handle runtime exceptions across your entire API without exposing stack traces? The trapped answer: I put a try-catch inside every controller. That creates duplicated code, bloated controllers, and inconsistent responses. The senior answer? Use the native IExceptionHandler approach in ASP.NET Core. Instead of handling exceptions separately in every endpoint, create a centralized exception pipeline, and then return standardized ProblemDetails responses. Your API can provide the correct HTTP status code, a trace ID, a safe error message while keeping the actual stack trace away from the client. And there's another important distinction. Not every error should be treated the same way. A domain validation error is different from an infrastructure failure. For example, a user entering invalid data should not look like a database outage. Your API should translate domain exceptions into appropriate problem details responses. Meanwhile, your logging system, such as Serlog or Application Insights, can capture the complete exception details internally. The client gets a clean, standardized response. Your engineering team gets the diagnostic information. That separation is what makes the architecture production ready. Scenario number 3. Outbound HTTP calls and performance. Imagine your API needs to call another microservice millions of times per day. The interviewer asks, how do you manage those outbound HTTP requests? The trapped answer? I create a new HTTP client inside my service method, use it, and dispose it. Sounds clean, but under heavy traffic, this can lead to socket exhaustion. Why? Because TCP connections can remain in time_wait. Now imagine doing that thousands or millions of times. Your application can eventually run into serious networking problems. So what should you say instead? Say, IHttpClientFactory. It manages HTTP client creation and connection reuse more effectively. And if you really want to impress the interviewer, go one level further. Talk about modern resilience pipelines using Microsoft.extensions.resilience, powered by Poly. You can configure retries with exponential backoff, circuit breakers, and request hedging. Why? Because production systems don't just need to work when everything is healthy. They need to remain reliable when downstream services become slow, unavailable, or unstable. That is the difference between writing an API and engineering a resilient system. Scenario number 4. Rate limiting and high throughput protection. The interviewer asks, how do you protect your API from abuse, scraping, or sudden traffic spikes? The trapped answer? I'll write custom middleware that stores IP addresses in an in-memory dictionary. That approach breaks down quickly in distributed systems, especially when your API sits behind a load balancer, Cloudflare, or an AWS ALB. Instead, know the built-in ASP.NET Core rate-limiting middleware. You should understand 4 algorithms: token bucket, fixed window, sliding window, and concurrency limiter. And here's the architect level detail. Don't always rate limit purely by IP. You can partition limits using user claims or tenant IDs. And in a distributed environment with multiple API instances, you need a strategy that works across the entire system. That could mean an API gateway such as YARP or Azure API Management, or shared state through Redis. Now, scenario number 5, minimal APIs versus controllers. If the interviewer asks, when would you choose minimal APIs? Don't say they're only for small apps. That's an outdated answer. Modern minimal APIs can absolutely be used for enterprise applications. The key is organization. Use things like root group builder, extension methods, vertical slice architecture, and endpoint filters using IEndpointFilter. That lets you keep cross-cutting concerns like validation and authorization out of your core business logic. So remember these 5 scenarios: modern API security, global exception handling, resilient HTTP calls, rate limiting, and minimal APIs at scale. Master these, and you immediately separate yourself from developers giving outdated interview answers. I've documented the architecture diagrams, code snippets, and interview answers in a free LinkedIn PDF cheat sheet. Check the pinned comment to grab it. And subscribe for part 2, where we'll cover EF Core 9 performance hacks and Web API thread pool starvation. Which of these 5 scenarios surprised you the most? Drop it in the comments.